Hi.
Can you hear me?
Yes.
Okay. This will be our last handout session before our final exam. Just want to catch up with people and see how things are going with them. Either they have questions about the projects or about final exam or about term-long projects. I actually took some time to review their proposals. So anybody want to talk to me about their implementation or status, it is a good time we'll talk about them today. Do you guys have any questions about your search engine project or anything to, I suppose today is the deadline, right?
I have a question about the twistor k-means.
Yes, go ahead.
It's kind of in the low level in the weeds, but I wanted to know more about the data structure, like the fundamental data structure that's used in that, which seems to be the double vector data type.
Yes.
It's used for centroids and it's used for individual data points.
That's right.
And it has an extra field for the length of the vector, or the number of entries. Let me see.
Yes. So.
In other words, I understand the overall concepts, but the implementation here with the data, the proprietary, in a sense, data structure is a little bit confusing to me.
Right. So the data structure we used for our template or suggest students to use really is array. You can call it a vector. And we give students like the data points is x, y, two-dimensional, but we can extend that to high dimension arrays. So the extra data structure we add to the x and y of coordinates is the label or counting, which cluster it belongs to, or counting the numbers. So that's about it. And basically, it's a array of doubles or floating points consists of the coordinates of the data points. and plus the extra field, so that we can label the cluster or we count the number.
See, that was really confusing. So when I was looking at the data files, I thought they were in 3D because they have 3 entries.
Right.
But it actually shows that the last one is a cluster ID, and not an actual XY. It's not a Z coordinate.
Right.
No wonder I couldn't get it though.
Right.
Okay.
We make it very simple. It's XY. In reality, the clustering algorithm is very general algorithm, can be used for different data types. So, for instance, we even use clustering algorithm on image data. You can imagine it's not even XY. It's a very high dimensional data points.
Well, I spent a lot of time trying to figure out how they were getting a 3-dimensional vector space into 2D double array, and so I came up with some ideas, but it was pretty bizarre. So it's good to know that that's not what's going on.
Right.
But it does say 3D somewhere in one of the assignments that the data is in 3. So that was confusing as well.
So we actually, I believe the data is actually 2D.
Yeah, right here it says in homework unit 11 on Cloud MOOC that each computes a partial cluster center by going through the corresponding 3D data points.
Yeah. If it's 3D, actually, it's a little bit, it's similar, but just add another dimension. And
yeah, of course. Yeah, you need another dimension to the array. So I was really confused on that. Okay.
Yeah.
Has anybody else done this assignment? Anyone?
I think there are at least 4 people already submitted their homework on this. I was actually quite impressed by the online class. The reason is that in the residential class, they have a group of 3 students doing each of the project. And at the very beginning of this class, I was trying to figure out if students would like to group together. It seems that they prefer to do it on their own. So that means that if they can finish the project, which is equivalent to the requirement for the residential class, they're actually doing very good because they mostly do the work by themselves. And the number of projects and all this kind of things, I think is quite intensive for one semester, because each of this technology you can expand to do a lot of things. Like for Hadoop, it's a big topic because that is a major tool in data processing. So I think that a lot of you are doing very well in this regard, and some of you also proposed the term project. I was very impressed. For instance, Greg proposed a project. He's trying to utilize the indexing. It's quite similar to our search engine structure, but rather he's processing the data, try to find text in different PDF files. But on top of that, I also propose to do ontology. It depends on how complicated is ontology, but I think that is a very interesting way to extend what you've learned in this class, because you have the basic structure, how to load the data effectively, how to do queries, and then now you want to apply to different type or different application, different data. I think that's pretty interesting, but you need to clarify how complicated ontology you want to work on. Another example I can give you as students proposed to study the clustering algorithm, obviously very, very, very generally used. So this student tried to study a variety of clustering algorithms. Some are constrained, some are pairwise based, some are different optimization. So my suggestion is that if they do this, they better set up metrics to validate this variety of implementation, what they look into, and what is the quality of the clustering result. For instance, you can compare like we have k-means clustering, right? Obviously, you have data points, you find the clusters, and you can calculate the cluster center and how many data points belong to this. If you choose to compare different algorithms, you need to have a metric to validate what the distance and how much the difference between the clusters. So I think that will be very interesting. You basically tell us the quality of the different clustering algorithm variations. And in my residential class, I have a few very interesting projects. It's sort of one of them is that I found is very interesting is that students using Android phones to connect to cloud. And this is the area I'm always interested in because Internet of Things is obviously a very promising area. Now people make it smaller and smaller. It could be iPad, it could be Google Glass, could be anything, wearables and things. So the major issue is that you can take this Internet of Things as sensors, and these sensors will collect all the necessary information. It could be GIS location. This is very popular. You can collect this information to utilize that to locate where your cellular phone, where you are physically located, and then couple with other applications. So this is a very interesting project that we're working on with students. Another one that I was on travel at Microsoft last week, and was a very interesting project and we have is that right now in this class we package all the tools in the VM. So in the first lab you download the VM and set up the testing environment, and this is the common method. People doing tutorial, people doing class, anything related to programming, either online or in face-to-face in physical class. But if you extend the thinking about the cloud and about your desktop, actually there is one way to make it very hybrid. What happens is that on your desktop, it's a workspace. It's your workspace because that is your client workspace. And if you download the VM to your laptop, it means it's a sandbox. However, there are VM resources on Amazon. They could be VM resources on FutureGrid, could be on Google, could be on Microsoft Azure, could be on anywhere global-wise. So what happens is that you could, if we provide the infrastructure to burst the resources to the different commercial academia resources, and not only VMs, but also the storage, then your workspace will extend to not only your local, but global. This is what we're doing right now. We want to collaborate and do that. So if that is implemented, and in our class, you will be on your desktop, be able to see you have an application like you run a Hadoop, you k-means or whatever you do, and you not only run on your client in a sandbox to simulate, you will grab the resources from different cloud, whatever is available, and you run a schedule on them. The system will transparently link all these resources together so you can run them. Underneath this, the technology is bursting. You need to set up VPN to negotiate with different kind of domain providers, ISP. So you log in as an IU student. You think the resources of computing and storage are from a part of IU, but actually they're not. They're bursted to commercial cloud or some places. So there are a lot of interesting things going on in the infrastructure space, as I mentioned. And then at the platform space, it's also, as I mentioned, class, we really focus a lot on the platform because you have all the tools to do data processing. So I think it's a quite exciting, time because people are building new tools to be highly efficient. Some of you even actually trying to study, several students interested in study different non-SQL databases. If you have application, they basically ask the question, which one to choose? You can choose HBase, you can choose Cassandra, you can choose React, and how do you choose? What's the difference? So this gives you a very rich perspective from different level of tools you can use. If in any case you cannot finish even if you have had the plan to do a term project but you couldn't finish, it's also fine. Normally it takes 5 to 8 months to do a decent project to publish a paper. So if you don't have time at this moment to finish, then it's okay. You can think about what you want to apply, to your, interest topic or to your work. This is just a start. This course will just get you the basic concept, get you started. If you want to get credits for your term project, I do need you to submit your report. You need to show either you did survey very well or you do some simple testing to show the concept, to show the result, tell us, what the difference. You have to show either way. I can get you credit. If you cannot finish that, that's perfectly fine as well because there's a lot of work on your project already. And then just complete well of your course project. Each of them, we'll carefully select them. If you fully understand that, you can actually extend them to address other problems, similar problems. So that is the whole purpose of of design as a hands-on things. Some of you asked about the final and how to review and what will be covered, and so I sent the email. So what I will do is that it's relatively straightforward. The basic concept part, I will definitely ask questions on what you'll focus on, the platform, the Hadoop related, concepts, the iterative computation. These are really related to data analysis, data mining, anything that is a state of the art. And also, I'll ask questions about basic cloud concepts. How do you, distinguish the cloud infrastructure versus other, kind of platforms? The last question I will ask is really about your course projects. You have done a lot of course projects, and I will ask some specific questions and to see how well you understand, how well you have done your projects in programming perspective. It shouldn't be the level of difficulty will be the same as midterm. It's really not that difficult, but it needs some thoughts to help you to review, what you've learned. What my plan is that I hope that if you can read through the book chapters, you get enough context information or terminology so you can talk to people, what they're talking about. And the class project, I hope that after you've done that, you have enough experience. You really can go ahead, apply those to implement something related to, real problem or, whatever topic you're interested in. So I want any of you to ask questions, related to how we wrap up things, how we help you to, review, or any questions. So Linger is also there. Supa, are you there as well?
Yes, I'm here.
Okay, great.
To unmute my. Can you hear me, Jody?
Yes.
All right. I did send you an email earlier on in the week regarding doing something with HBase database. No SQL HBase, no SQL database.
Yes.
Okay, because that's my area of of employment right now, and then I've focused for that's one of the big drive motivations why I took the class to begin with. So how extensive do you want, because I talked about doing something with HBase and you said okay, Jive and HBase, that's fine, that would be interesting topic to do. So what's the extent that you want me, I mean, it's just like doing is it like a comparable paper is gonna do analysis of how Hive, excuse me, would use HBase, or what's the extent?
Yeah,
What are you?
that's a very good question. So depends on that, how much time you have to contribute to this turn-on project. The easiest, I think, is survey. I sent you some material with references.
Okay.
You can look at a list of related, non-SQL databases. And usually, even my students who does the research in this area, the first thing they do is survey and look at the literature and draw a table. I told them you can draw a table. You compare each of this technology with columns. So you need to tell us each of the non-SQL databases, do they have, what is type of consistency? This is very fundamental they use. And to what kind of targeted read and write rate they're targeted for. Usually databases, you save data, load it into query, right? And some of them write once, read many times. And if your database is targeted for a lot of updates, then that design will be very different. So you need to clarify in your metrics, tell us the different database, what they're targeted for, right? So I mentioned the consistency model, and then the read and write of the operation pattern, and then the architecture. What file system they sit on top of. For instance, HBase could be sit on top of HDFS, but some other database might use different data formats. Some support JSON, some support other data formats. So you need to clarify all these metrics. And then, okay. So this is the survey type. I think your phone is muted. Can you turn it on?
Yeah, I did turn it on. Okay. So say I pick about, say, 2 or 3, say HBase, MongoDB, and something else. How many non-SQL databases are you looking at potentially doing a survey for?
I think that major non-SQL databases, there are 4 or 5. Okay. Cassandra, MongoDB, React, HBase, there's Solr, there's another one. So there's several of them, 4 or 5. I have in my residential class, students did a term project on compare Cassandra and HBase. So from this perspective, I just talk about survey. If you really want to, in your work, to do some real experiments, I tell you what they spend their time for. There are a lot of details of APIs. When you want to really make the different non-SQL work, you need to familiarize with that. That takes time. You can draw a table to list the metrics and the features from literature, but when you really do implementation, the time you will spend mostly is really familiarize with the interfaces of each of these non-SQL database, be able to program them. So that is where the students in our class spend most of the time. But it's very helpful because that is the experience they learned, so they can do it. It's sometimes not very trivial because because on the internet, the lack of complete documentation, you need to do some experiments. So that is something you can do if you're really interested in implementation.
Okay. I think I'll start with the survey, given the time time constraints and things like that. I think looking at the constraints plus, I think it's gonna just, given the nature of the class that we took and how we look at many different tools, I think this would be like an extension of looking at the different database tools that are available, so to speak.
That's correct.
So yeah, and doing a survey on them and with a table. I think that's where I'm gonna be looking at focusing.
Yeah, that's great.
Okay. Thank you.
Yeah. Another thing I want to ask is that my plan is that, and this time when I went to Microsoft, I met with people from Hortonworks. And Hortonworks, if you know that, if you Google, it's a organization just like a sort of a contributor of Apache projects. So there's a new trend that people really into building open source projects, tools, for obvious reason, because building software, it takes time, takes resources. So a lot of open source tools actually take a long time and get a lot of industry and community support. So now they have Hortonworks try to build several important software, including the Hadoop one, the HBase, the Hive, and all those. They want to make it very kernel tools for general purpose usage. And the good thing is that these people not only build the open source tools, they also build a lot of tutorials. So when we try to utilize those tools, they will support to allow us to utilize their tutorials. So students can have the sample to run the test code, just like in our class. We'll provide the VM so that you can get very quickly familiarized with their examples and be able to test out their tools. And on the other hand, I want, if there's any good work from our class, I really want to archive them very well. So I want to put as a repository for my class for students' work. That's exactly what I did at the beginning of the class. I present your senior students' work to show what they have done, and not only show their PowerPoints and report, I also have their source code. So I will gather those as the examples. So I will need to get your permission if you do some good work on your project, on your term project, or anything. I will collect all those things and try to archive them well. So in the future, we have repository keep evolving. So in the future, other students come to this class, I will show them, especially some very good work. I will select some to show them what the students already done, and if they're interested in expand the work or just take a look what have been done, then that will be great. So we need all those examples. Right now, our infrastructure is not totally built up. So if it's all built up, we want to have your work saved in the GitHub or something, but also we package something in the VMs, put in the repository like FutureGrid. So if students want to study system work, they can bring out the VMs just to play with that, just like what you did in FutureGrid project. You have Hadoop. We prepared Hadoop VM for you. And you have a lot of tools that you can play with in the cloud space. And you can bring the VM, try to schedule it in an elastic fashion. This time you run on 2 nodes, or maybe next time you run on bigger, like 10 VMs to do experiments. So I want to collect all those kind of projects, try to utilize them as the examples. So any of you turn in your homework, and I hope you can archive very well, and also you do comments on your source code. Just the style is very readable and things like that. That will help that we accumulate all this kind of course materials. Anything else I can do for you? Of course, you have to do the work.
Hey, Judy, this is Chris. I was wondering if we can keep the Twister K-means project open, turn-in date pushed back to coincide with the term project, because I want to do something that's related to the K-means, so they're kind of one-two punch. So I was thinking about doing a little clustering project with some data that I have at work, but I need to get this K-means twister working right, obviously, before I do that.
Yeah, that would be great.
I think it's short enough scope we could do it the next.
How long do you expect you need? The time?
Well, obviously, I only have a week, right? So it's just it's more data than I can cluster, on one process or something on typical architecture, so it would benefit from this environment. But I need to get the twister K-means working first, because K-means is probably the algorithm I'll apply to this clustering data as well, this other data set.
Yeah, that sounds fine.
They would be both turning at the same time at the end of, by May 11th, I suppose, next week. Right.
So just keep in mind, our final exam will be May the 11th. So that means that after that, we'll have a short turnaround to get all the grades, done, and then post it to the system. So usually, university require us to turn in the course grade within 3 days, but in practice, it's 1 week after the final. As long as you can finish everything, before that period of time, then I can, give you credits.
Okay.
But on the other hand, if you're really interested in using these tools, I can tell you is that we do use Twister K-means to do real application, and the size of the data we can process is very large.
That's why I was wondering about the different data structures or API, or if everything we have here is sufficient for any dimensional. I mean, the dimension there is many more than 3 or 4. It could be 100 or 200 space.
That's right.
So would this API as it's given to us in this class scale to that?
Not exactly. You need to change your data structure. You can't do that. I mean, the whole control flow is the same, but the data structure needs to be changed. And we also need to have better communication APIs than this one. In this class, this one is sort of a non-optimized for high performance. So if we deal with really large data sets, like we broadcast actually each map type 2 gigabytes of data. What does that mean? It means that if you look at your memory size, really for small memory machines, that's like 16 gigabytes, or maybe bigger ones is factor 2 or 3 bigger than that. So each map task broadcasts 2 gigabytes. So that means it's very, very large, because you might have 8 map tasks or 16 map tasks. So the size of the intermediate data is even larger than the memory size can hold. Obviously, the direct tools will not work. So we have a lot of optimization for communication. We can to process much in really big data. So in our class, we actually have the prototype is simplified. For many reasons. First, that if we first time teach you, we cannot make it too complicated, because you need to get through the basic concept. Secondly, usually we may not have the resources like 100 nodes or large cluster for you to run on. So there are many reasons we make it simplified version. And my recommendation is that make the current prototype version work, so understand the mechanism. And if this type of tool really would be useful for your work or anything, and we can talk about that, how to give you the real, infrastructure, and then show you how that can be applied to a much larger scale. That really need also resource allocation and other things to make it work. Does that answer your question, Chris?
Oh yeah, now I'm scared though. So never mind. No, yeah, it answers it. It's just well, maybe I'll think about if it'll be useful even on this small scale prototype. I think in terms of learning, it still accomplishes the goal, but it would be nice to actually get some usable data out too, some stats.
Yeah. Some of the tools, this is not a joke, but some of the tools actually is quite complicated to set up. I have a group in my residential class. They're trying to do the Giraffe, the graph-based tool. It's a counterpart, of Twister and things. They eventually couldn't work it out, partially due to the constraint of time, but partially it's quite complicated to set up those tools.
Sure.
So yeah, so in some cases that the tools need some, detailed instructions on how to make them work.
Is there a future grid implementation that's available, or would that be too much to where everything is set up already?
Yes, on future grid, some tools they already set up as VMs. It will be much easier for you to use them. Like there is a tool called MyHadoop. We create that is created by San Diego, and we create a tool as MyHBase. Basically, what we did is that we packaged all the scripts. So it's one click. They automatically install everything for you to configure those things. And some tools not exist, so you have to manually claim the VMs. You manually configure, do those things.
Okay.
How do you want to? I mean, I'm just curious. After you learned things, did the homework in this class, how do you want to integrate that with your work? Is there anything you can relate it to your work?
Oh, Judy, can you hear me?
Hi, Greg.
Oh, yes. I'd like to be able to try the sort of like an extension of the term project that if I'm, I'm going to try to complete as much as I can, but I'd like to actually do it for real at work. So that's sort of my one of my goals, I guess.
So according to your timeline, you already have done the project. Right? May 2nd is your deadline.
Oh, I have started some of the project at work, but the sort of the ontology searching part that I proposed and for the term project I haven't done that. But that's something I'd like to try on a small scale for the first project, and then on a larger scale at work.
Okay. That is fine. I have in my residential class a few groups talk to me. So they actually were interested sometime in summer to continue the work that what they have done so far in the class. Like one of the projects they're interested in, as mentioned, is the Internet of Things, Android phones. What they're trying to do is that they try to utilize that GIS to locate people, and then at the back end in the cloud, try to run an algorithm and try to see who are the nearest neighbors they can couple. And they can also select that if they know these people, their preference, try to run some recommendation systems to show what music they want to play for those people. So they're very interesting, collaborate the work between the phone and the back-end processing capability in the cloud. So if you guys I have a constraint. I need to give you a grade if you have a term project. As I said, the deadline will be 1 week after May 11th. But if not for the grading purpose, then you're really interested in, you need to do something related to your work, or you're interested in accomplish something, we can probably do something during the summer. I have more time in the summer other than travel.
Okay. Yeah. Is it okay if I after the course send you an email if I have a question on something?
Yeah, email is fine.
Okay. Right, thanks.
Yeah, Judy, I'm interested too. As a matter of fact, I think I'm more interested in working more after the class is over, if I'm especially unable to finish some of my stuff, working more in the summer, get a lot of more stuff done and learn more. Like I said, I'm more interested in the HBase, the NoSQL DBs. If we have more, if I can, I'm looking more at HBase, but if I can look at more of, say, MongoDB, looking at them practically as well, then I'm more interested in doing a whole lot of that in the summer as well. Because again, like I said, at my job, I'm in the database side of things, and of course, we're looking at building warehouses, data warehouses, and in the future, it's a matter of time before we start looking at Hadoop and HBase and all that good stuff to help. Because the biggest part of what we're facing a lot of time with this data warehouses is performance. And this right here is helping with performance and scalability and parallelism. So this all goes along lines of what we're doing at my work. So it's imperative that I try to know as much as I can. That's what I'm learning, and I want to keep this process going through the summer as well. So I don't know how much I'm going to get done in the next week or so, but then I'll email you and then ask you if I can extend my time to in the summer as well and continue working.
Yeah, that's fine. I think that actually will work out better. Yeah.
All right.
And also related, I sent you the document of related work. So we do have active project in those areas. So I'm pretty optimistic we can help you with something.
Okay.
At the end of this class, this is an online class for certificate. We'll definitely give you guys certificate. But also, as I mentioned in my email, there are quite a few exceptional work because you did all the project by yourself. A lot of time you have to, try to twist what's the things, work and things. I'm sure it's a very good work. On the other hand, we really want to do recognition. So we also have some, letter of achievements for you. And so I hope that there's 1 or 2 weeks to go. I want to wrap up things up. If there's any homework you left behind, you're missing or anything you want to make it up, please tell your AI you intend to do that and try to complete the things. At the end, we'll have a big equation about all your homework, everything that you've done. And then we'll give you the course grade.
Okay.
I will hand it over to Supan and Linger.
Hi everyone. If you have any questions regarding the project, those things, let us know.
Does anyone have issues with the search engine project or any other projects you want to finish them?
Yeah, I haven't even looked at it. I haven't done that one.
All right. Okay, if there are no more questions, we will go offline, and you can still communicate with email. I guess you need time to work on your thing. And if you're interested in complete the term project, even after the class finish, please just keep up and contact me, and we can talk about how to, help you to accomplish what you want. All right. Thanks everyone for joining the Hangout, and we'll see you next week. All right, bye.
Thank you.